Good morning. Oh, just let me turn on the lights. Hopefully that's better. So today's lesson is a continuation from yesterday. Yesterday we were talking about the slope formula, and you'll find out that the slope formula is very useful for what we're going to do today. What we're going to take a look at today is the first of three different ways that you can write the equation for a line. And the first one, as you can see behind me, is called the slope-intercept form. The reason it's called that will become obvious shortly. Anyways, before we do that, we have to take a look at a couple of definitions. The first one is y-intercept. So if you take a look, you have a coordinate plane. If you have a line that's graphed on that plane, most of the time, unless it's a perfectly vertical or perfectly horizontal line, most of the time it's going to cross both the y-axis and the x-axis at some point. The point where it crosses the y-axis is referred to as the y-intercept. And I just remember that that's because it intersects the y-axis at that point. Okay? Similarly, that line will also intersect with the x-axis at some point, the horizontal axis, and oddly enough, that is called the x-intercept. And that's right there. Okay? So you have these 2 points, the x-intercept and the y-intercept. Okay, we're going to talk mostly about the y-intercept today, but you need to know that at the y-intercept, as with any other point on the line, you're going to have an ordered pair that describes it. And at the y-intercept, the x-coordinate will always be 0. Okay? The y-intercept, or the y-coordinate, can be any y value. It will just be the number where it crosses the line on the y-axis. Similarly with the x-intercept, so we'll just call this, for now, we'll just call that the y-coordinate. With the x-intercept, it's kind of the opposite, okay? For all x-intercepts, we know that the y-coordinate is 0, right? Because it's neither above nor below the line, it's right at 0 for its y-coordinate. And then the x-coordinate will be some x value, okay? So, x-intercept, y-intercept. The other thing that you'll use in today's lesson is the thing that we've already spent 2 lessons talking about, and that's the slope. Okay? So, the slope, remember, takes the variable m. Okay? And the slope-intercept equation is right here. This is the generic form of the slope-intercept formula. Okay? It's y equals mx plus b, where b is your y-intercept, and m is your slope. Okay? So m is the slope, b is the y-intercept, and the other 2 variables, x and y, would be the x and y coordinates of any point on the line. Okay? Excuse me. So, let's take a look at some examples. Okay? keep in mind that you can put any equation in this slope-intercept form simply by isolating y. Okay, and we'll do some of that later. But any linear equation can be put into this form, y equals mx plus b, simply by isolating y and moving everything else to the other side of the equation. Sorry, I got a frog in my throat. Okay, so let's take a look at some of these. Here's an example of a linear equation. Remember, it's in the form y equals mx plus b. And as soon as you see that, you can see that this number here is your value for b. This number here is your value for m. Okay? So, the value of m is always the number that's attached to your x variable. So that means the value of m in this case would be 1/2. Okay? And therefore, because m is just the slope, if you know the value of m, you know the slope of the graph. Okay? And remember from yesterday, we said that slope is rise, change in y, over run, change in x. So that means this slope is a set of directions. Remember that. Slope is just a set of directions telling you how to get from one point on the line to another point on the line. In this case, since our 1 is positive, we know we would have to go up 1. Since our 2 is also positive, our change in x, it means we would have to go right 2. Okay? So if we have a point on the line, to get to a second point, we simply apply the slope, the directions. Okay? So let's find a point on the line. Okay? We have a table of values here. We've been given a couple of values for x, and we can use our equation. I'm just going to erase this. We can use our equation, if we know the value of x, to find the value of y. So let's do that. So for our first one, if x is -2, we simply substitute the value, -2, wherever we see x, and then simplify the equation. Okay? So, 1/2 times -2 would just be -1 plus 3. -1 plus 3 gives us a y value of 2. Okay? So when x equals -2, y equals +2. Now we're not going to do this for every one of these, but we'll do just this second one. Okay? What about if x has a different value? If x has a value of 2? Well, then we substitute the value of +2 this time. 1/2 times +2 is 1, and 1 plus 3 gives us 4. So when x equals 2, y has a different value. Y has a value of 4. Okay? So, we have 2 points here, and we could very easily graph this line with only 2 points. All we have to do is plot them. So remember, if this is the origin at 0, our first point has an x value of -2. That means you're going to go 1, 2 to the left, and a y value of +2. You're going to go up 2. So our first point, right here, has a value of -2 and +2. Our second point, the x value is +2, so this time we're going to go to the positive, to 2, and a y value of 4, which will bring us all the way up here to +4. So, this is our first point, -2 and 2. This is our second point, +2 and 4. As soon as we have 2 points, we can graph our line. Let's Take Mr. Ruler, join the points, and we have our line. Now, take a look at where the line crosses the y-axis. The line crosses the y-axis right here, which you can see is between 2 and 4. It crosses the y-axis at 3. Now let's go back here. Our value for b, the y-intercept, is 3. And you notice that when you graph the line, it does cross at 3. Okay, so our y-intercept is 3. We'll do this one over again, and this time what we're going to do is we're going to use slope instead and one of our points. Okay, so the first time we did it, we plotted 2 points, we joined them up, and that gave us our line. This time, we're just going to take 1 point and the slope, and you'll see how we can also use 1 point and the slope to graph a line as well. So we'll take our first point again. It's at -2, 1, 2, and +2 for our y value up to, there's our first point there. Okay? Now, our slope, remember, gives us directions on how to get from any one point to a second point. So, if we start here, our slope tells us we have to go up 1 and right 2. So we're going to go up 1 to 3, and then we're going to go right 2 to -1 to 0. And look where that brings us. That brings us to our y-intercept. Okay? So again, the slope says you go up 1 and over 2. That brings us to our next point, which is our y-intercept. Now that we have 2 points, again, take Mr. Ruler, join the points, and you can see we have exactly the same line that we graphed before. Okay? So what am I trying to get across with this? I'm trying to tell you that if you have 2 points, or if you have 1 point and the slope, you can still graph your line. Okay? Now, let's just take a quick look at the rest of these equations. And the similarity with every equation here is they all have a y-intercept of 3. Well, what does that mean? That means that when you graph each of these lines, every single one of them is going to cross the y-axis at 3. Okay? Now, will they look the same? No. Okay? The reason they won't look the same is because each of them has a different value for the slope. And remember, what does the slope tell us? It tells us how steep the line is and what direction the line is going. So, this one had a slope of 1/2. This one has a slope of 2. So this is going to be a much steeper line, still going up to the right because it's positive. This one also has a slope of 2, but it's -2. So how is that going to be different? That's going to look like this. Now take a look at this one compared to this one. They have the same steepness, right? They both have a slope of 2, but since this is positive, it's going to go up to the right, and since this is negative, it's going to go down to the right. Okay? So slope tells you how steep it is and what direction. Y-intercept tells you where it crosses the y-axis. Hopefully that makes a little bit of sense. So, how does changing the value of m change the appearance of the graph? The lines, steepness, and direction will change. What does m represent? We've said this many times. The slope. Okay? Now, very quickly, I'm not going to go through and plot these points. We're just going to take a look at how these equations are different. Now, notice in the last set of equations, it was the y-intercept that was the same every time, and so we could say they all cross the y-axis at exactly the same point. In this case, take a look at our values for b. I'm just going to move this up a little bit. In this case, our values for b are different. This one is positive 3. This one is negative 3. This one is 5. This one is negative 6. So what does that mean? That means that when you graph these lines, they're going to cross the y-axis at a different point. This one will cross at positive 3. This one, on the other hand, is going to cross down here at negative 3. This one will cross at 5, and this one at negative 6. We can't really see that, so we're not going to worry about it. Okay? So what's different about them? The y-intercept. What's the same about them? Well, the thing that's the same about them, take a look at the slopes. This one has a slope of 2. And this one has a slope of 2, and look at this one. It has a slope of 2, as does the fourth one. Okay, so remember, the slope is the number that's attached to the x. Okay? So, if our value of b is 3, our y-intercept is 3. Similarly, negative 3, positive 5, and negative 6. Now, how's that going to change the way these lines look? Well, since each of these has exactly the same slope, each of them is going to have the same steepness and the same direction, right? They're all positive, so they're all going to go up to the right. They all have a slope of 2. So for instance, this one might look like this. This one, oops, might look like this. This one, like this. And this last one, well, it's going to go down here somewhere. Okay? So, what can you say about each of these lines, given that I've just drawn them freehand, so they're kind of crappy? Okay? Well, they all cross at a different y-intercept. That should make sense, because they all have a different value for b. But since they all have the same slope, they are all parallel. Okay? That will become very important later on. So, how does changing the value of b change the appearance of the graph? Each line crosses the y-axis at a different point. what does B represent? As we said before, the y-intercept. Okay? So, let's do a little bit more work with these that's a little more algebraic. So writing equations of lines using slope-intercept form. So if I give you those two important things, the slope of the line and its y-intercept, you can come up with an equation. Yes, I know you can. So the equation of a non-vertical straight line graph can be written in slope-intercept form. The equation is y equals mx plus b, where again, m is the slope and b the y-intercept. Okay? So, to write the equation, all you have to do is substitute the slope where you see m and the y-intercept where you see b. Okay? So, write the equation of each of the following lines. A linear function with a slope of 3 over 5 and a y-intercept of -4. So, our generic formula, y equals mx plus b, becomes, if we substitute 3 over 5 for the slope, instead of an m, we're going to write 3 over 5x. And it has a y-intercept of -4, so instead of b, we're going to write -4. Now, you can write it like this, but it's much simpler, rather than writing plus -4, to simply think of it as -4. Okay? Well, what about if it has a slope of -6 and a y-intercept of 2? Nothing could be easier. You simply substitute a different value for the slope. Our new slope is -6, so we're going to put a -6 there. Our y-intercept is 2, so instead of -4, it becomes +2. Pretty easy, hey? Okay, so you're just substituting. The important thing is you have to know where to put the numbers. Slope goes where you see m, y-intercept goes where you see b. Okay? Now, you can use the slope formula if you have a line to find stuff you don't know. Okay? So remember, we just did examples where we were given the slope and the y-intercept. With these examples, they're not so nice. Okay? You're going to have to figure that out on your own. Now, the y-intercept is fairly easy. It's the place where the line crosses the y-axis. So our value for b, the y-intercept, is obvious. We just have to look at the line. Unfortunately, our value for the slope, not so obvious. However, if we know any 2 points, we can find the slope. So, you can choose any points you want on the line, and if you sub them into the slope formula, you'll get the correct answer. Always choose points that are easy to figure the coordinates for. So, I would never choose this point here, because I can't tell if this is at, I know it's between 4 and 5, but I don't know if it's 4.2 or 4.3 or whatever, okay? So, be nice to yourself. Choose places where the coordinates are easy to figure out, okay? So because this one crosses through an intersection of grid lines, it's pretty easy to tell that it's 1, 2, 3 across, and 1, 2, 3, 4 up. The coordinates for this point are at 3 and 4. Similarly, for our y-intercept, this is a point and it has coordinates, and the coordinates of this point would be 0 across and 5 up. Okay? So, knowing the values of these 2 points, we can find the slope remember, the slope formula is y2 minus y1 over x2 minus x1. Remember we looked at that yesterday. Well, it was yesterday for me. We looked at that when we looked at the slope formula. Okay, so plug in the numbers. Here are our y values. We'll use this as our y2, so that becomes 5 minus 4, right? y2 minus y1 over 0 minus 3, x2 minus x1, which gives us 5 minus 4 is 1, 0 minus 3 is negative 3. So that tells us the slope of this line is negative 1 over 3. Okay? Now we're at a place that we were in the last question. We know the y-intercept and we know the slope. So the equation of this line in slope-intercept form, which remember is y equals mx plus b, becomes, sub in the slope, negative 1 over 3x, sub in the y-intercept, plus 5. Again, y-intercept is the b, negative 1 over 3 is the slope. Now, the slope is negative. That tells you this line should slope down to the right. Okay? If you get to this point and you ended up with a positive slope, then you must have messed up in your slope calculation. Go back and check your work. Okay? Let's try one more. We'll do it a little bit more quickly. Yeah, we'll do this one. Okay? So again, this is where it crosses the y-axis. So that tells us our value for b is negative 1. It crosses the y-axis at 0 and negative 1. Remember I told you all y-intercepts will always have a value for their x-coordinate of 0. Notice this one has an x-coordinate of 0, and the one we just did has an x-coordinate of 0 as well. So we've got one point. Now we have to find another, because remember, we haven't been told what the slope is. We have to figure that out as y2 minus y1 over x2 minus x1. So we need to find another point. Okay? We can pick any point we like. I'm going to pick this one right here, because I can see the line goes right through an intersection of grid lines, so I can be pretty sure what the coordinates are. And in this case, my x-coordinate is negative 2, my y-coordinate is negative 5. So negative 2, negative 5. Now that I have 2 points, I can plug them into my slope formula. So my y2 is negative 1, my y1 is negative 5. So m equals y2 minus y1. My x's, if this is my y2, this has to be my x2. So 0 minus negative 2. Now remember, subtracting a negative is like adding. So what we end up with here is negative 1 minus negative 5. We end up with plus 4, right? It's like saying negative 1 plus 5. Here, we end up with positive 2, which, more simply put, is a slope of 2. Okay? Again, take a look at your line. We have a positive slope, and yeah, it's going up to the right. So our equation in y equals mx plus b form becomes y equals the slope goes where your m is. Your y-intercept is negative, so minus 1. Okay? And there we go. Now, if you're given the equation, it's actually quite a bit easier. It's like the first thing we did. So we'll do these fairly quickly. the instructions say graph the following lines using the slope and the y-intercept. So, the y-intercept here, because it's -1, that means it crosses the y-axis right there. Well, how about this one? This time the y-intercept is at +5, so that means it crosses at 5. Okay? So, again, if we have the equation, it's really easy to plot the y-intercept. To get a second point, because remember you always need 2 points if you want to graph a line, we go to the slope. The slope here, and again I'm going to write it as a fraction, is 2/1. The slope here is already a fraction. Okay? Now, remembering that the slope is equal to rise over run, or delta y over delta x, that means a +2 means we're going to go up 2. A +1 means we're going to go right 1. Similarly, over here, change in y over change in x means this time, because our y is negative, we're going to go down. Remember, down takes you towards the more negative numbers, up takes you towards the more positive ones. Because our delta x is a +3, we're still going to go to the right. Okay? Again, because right takes us to more positive numbers on the x-axis. So, going back here, we have our starting point at the y-intercept. To get to another one, we have to go up 2, 1, 2, and we have to go right 1. There we go, there's our second point. Once you have 2 points, the rest is easy. Take the ruler, join the points. Similarly over here. Here's the point. This time our y change is to go down 2. So we're going to go down 2. Our x change is to go 1, 2, 3 to the right. There's our second point. Join those points. That gives you our second line. Okay, and again, very quickly, negative slope, down to the right. Positive slope, up to the right. We are so smart. Let's just very quickly do this example. Because at first, it seems like you don't have enough information, right? All these other ones gave you a y-intercept. If you have an equation like this, it has a y-intercept, it's just that y-intercept is 0. And that's possible, right? Your line could cross the y-axis at 0, and then that 0 wouldn't show up. You would just, it would be assumed that you would know that. Okay, so be careful. If you get an equation that looks like this, and there's no constant term, there's no number that's being added, that means your value for b is 0. So it crosses at 0. Okay? Now, our slope tells us that from our initial point, we have to go +5, that means up, +3, that means right. So to get to our point, we go 1, 2, 3, 4, 5 up, 1, 2, 3 to the right. Look, we did it. I won't join the points, you know the deal. You join the points with the ruler. Again, your line is going to go up to the right, indicating you have a positive slope. Okay? Now, this is where some of you are going to have some difficulty, okay? Because you have to rearrange equations. Now, you've done this many times. You've done it in the measurement units. You've done it in the physics unit in your Science 10 classes. Remember, in order to be able to extract that information about the slope and the y-intercept, your equation has to be in slope-intercept form. It has to be y isolated, everything else on the other side. Now, these equations don't look like that, right? The y isn't isolated. So we're going to have to do that. We're going to have to rearrange the equation. So let's do that. You want to get y all by itself. That's going to involve doing two things. You have to get rid of this entire term, the 2x, and you have to separate the 3 from the y. Now, right now, this is multiplication, right? 3y means 3 times y. When you isolate variables, remember, you always do the opposite of order of operations, okay? You do subtracting and adding first, dividing and multiplying second. You deal with exponents third, and you deal with brackets last, okay? So, very quickly, we want to get rid of this 2x. We're going to subtract 2x from both sides. 2x minus 2x leaves us with 0, and we have negative 3y equals negative 2x plus 12. Remember, you can't combine these two terms. They're not like terms. Okay? Great, we got rid of the 2x. Now let's get rid of this minus 3. Notice the subtraction stays with the 3. So, to get rid of this negative 3, since it's multiplied, we have to divide. And when we multiply and divide, we have to multiply and divide every term. Okay? So we divide this by negative 3, this by negative 3, this by negative 3. Well, negative 3 divided by negative 3 is positive 1. We're left with y. That's what we wanted. Negative 2 divided by negative 3, well, we're going to leave this as a fraction, but a negative divided by a negative, we know that's going to give us a positive answer. And plus 12 divided by negative 3, positive divided by a negative will give us a negative answer, negative 4. So, what's the y-intercept? Negative 4. What's the slope? 2 over 3. Okay? We'll do one more of these. We'll do a particularly nasty looking one. We'll do number 6 here. Okay? So, remember, isolate y, and then you'll have your slope and your y-intercept. Okay? So, for this one, to isolate y, we've got to get rid of the 3x, we've got to get rid of the 24, we've got to get rid of the negative 8. So, get rid of stuff that has to be added and subtracted. We'll get rid of this 3x. So we're going to add 3x to both sides. That'll cancel on here, and you'll have minus 8y plus 24 equals 3x. Okay? Then we're going to get rid of the 24, because it also has to be added, subtracted to get rid of it. So we're going to take away 24 from both sides. Again, it'll cancel. We'll be left with negative 8y equals 3x minus 24. Again, you can't combine these. They're not like terms. But it's starting to look better. Okay? The only thing left to get rid of is that negative 8. And since it's multiplied by y, to get rid of it, we must do the opposite. We must divide everything by negative 8. Well, here, negative 8 divided by negative 8 is positive 1. That leaves us with y. For this one, let's just leave it as a fraction. I don't want you changing these to decimals. We'll just write it as negative 3 over 8 times x. Okay? For this one, negative 24 divided by negative 8, a negative divided by a negative will give us a positive value. And so, what's our slope? Negative 3 over 8. What's our y-intercept? 3. Okay? Remember, if we have these two pieces of information, we can graph the line. Okay? And for our last question of the day, we're going to do that. Okay? We'll do number 2 here. So the instructions are to rewrite the following equation in the form y equals mx plus b. In other words, isolate y. Once you've isolated y, then you can very simply graph the line because you'll have the y-intercept and the slope. Okay? So we'll do this one because it looks meaner. So step 1, isolate y. We need to get rid of this 4x, we need to get rid of this minus 12, we need to get rid of this 6. So we're going to subtract 4x from both sides, giving us 6y minus 12 equals negative 4x. Then we're going to get rid of the 12 by adding 12 to both sides. Minus 12 plus 12 is 0, leaving us with 6y equals negative 4x plus 12. Last step, get rid of the 6. And again, because it's multiplied, if we're breaking those two parts apart, we have to do the opposite. We have to divide every term. Remember, multiplying and dividing is by every term. Every term is divided by 6. So 6 divided by 6 leaves us with 1y. Negative 4 over 6, we could write that more simply as negative 2 over 3x, right? Common factor of 2. And then finally, 12 over 6 is positive 2. Okay? Now, we now have the slope, we have the y-intercept, we have what we need. So, if our y-intercept is 2, we know that we have a point right there on our line. If our slope is negative 2 over 3, that means we're going to go down 2, right, negative, and right 3 is positive, from our point. So down 2, 1, 2, right 3, 1, 2, 3. There's our point. Join them up. Ta-da! Our slope is negative. Our line is going down to the right. Our y-intercept is 2. It crosses at 2. We are geniuses. And that's the end. See you later. We're going to do the second half of this in the next video because I've already talked way too much. Anyways, bye.